This is my fourth video lesson for Unit 14. In this lesson, we'll be balancing redox reaction. Go to page 15 in the class packet. Motivation, what is wrong with this reaction? If you notice, the masses are balanced, but the charge is not. The total charge of the reactant side is 2, but the total charge of the product side is 1. Learning target. At the end of the lesson, I'll be able to balance redox reactions. Homework be number 4, which be a Junipod based off this lesson. There'll be a quiz Junipod on PowerPoints 1, 2, 3, and 4. To balance a redox reaction, the law of conservation of mass and charge must be observed. The number of electrons gained is equal to the number of electrons lost. We'll go over two methods of balancing redox reactions. The first one is the table method. This is similar to the table method we use in stoichiometry. The first step is to figure out the total charge of the reactants and products and the number of reactants and products. Let's look at the reactant side first. Lithium has a charge of 0, magnesium has a charge of 2. So the total charge of the reactant side is positive 2. There is 1 lithium and 1 magnesium on the reactant side. For the product side, the charge of magnesium is 0 and the charge of lithium is positive 1. So the total charge on the product side is positive 1. There is also 1 lithium and 1 magnesium. Notice that the conservation of mass is observed, but the conservation of charge is not. To balance the charge, we're going to put a 2 in front of the lithium ion. Now the total charge of the product side is 2. But now we have 2 Li on the product side. Therefore, we need to put a 2 in front of Li on the reactant side. Now our redox reaction is balanced. The second method is the half reaction method. The first step is to write the half reaction for the oxidation and reduction. Lithium is being oxidized and magnesium is being reduced. From the half reactions, we can see that the number of electrons gained is not equal to the number of electrons lost. In the oxidation half reaction, 1 electron is lost, but in the reduction half reaction, 2 electrons gained. So we need to double the oxidation half reaction and put a 2 in front of the lithium and lithium ion. Learning check number 1. Given the unbalanced ionic equation, when this equation is balanced, both iron plus 3 and iron will have a coefficient of what? Pause the video and resume as completed. The first step is to figure out the total charge on the reactant side and product side. The total charge on the reactant side is positive 3. The total charge on the product side is positive 6. Therefore, we need to put a 2 in front of the iron 3 plus, so the total charge on the reactant side becomes positive 6. We need to put a 2 in front of the iron, so the number of iron on both sides is the same. Since it is positive 6, 6 electrons are transferred, so the answer is choice 2. Learning check number 2. Which redox reaction is correctly balanced? Pause the video and resume as completed. We have to check for conservation of mass and charge. In the first choice, the number of Cr on both sides is not the same, so choice 1 is wrong. For choice 2, the number of lead and hydrogen on both sides is the same. The total charge of the reactant side is positive 2. The total charge of the product side is also positive 2. So the answer is choice 2. For choice 3, conservation of charge is not observed, so choice 3 is wrong. And for choice 4, conservation of mass is not observed. Learning check number 3. When the equation is correctly balanced using the smallest whole number coefficient, the coefficient of lead positive 2 will be what? Pause the video and resume as completed. One way of tackling this question is using the half reaction method. You write the oxidation and the reduction half reaction. As you can see, lead loses 2 electrons while gold gains 3 electrons in the redox reaction. To balance this, we need to look for the lowest common multiple between 2 and 3. It is 6. So we're going to multiply each lead by 3 and each gold by 2. Now let's check if it's balanced. We have 3 lead and 2 gold on both sides of the equation. The total charge of the reactant side is positive 12. The total charge on the product side is also positive 12. So the answer is choice 3. Try to do questions 1 to 15 on your own. Balance the following redox reactions. Pause the video and resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Junapah homework and quiz.